So, today we're going to start talking about how climate affects ecosystems. Can everyone hear me? Okay. We're going to start talking about how climate affects ecosystems. Tomorrow, we will start talking about more effects that we are seeing right now. And then, Monday, we're going to start talking about how climate will affect us both now and in the future. So today is going to function kind of like Monday was, where we've got I think it was Monday, it might have been Tuesday, where we have a relatively short lecture followed with some more in-depth thought questions rather than an exit ticket. So we're going to start actually drawing connections between the stuff that we've learned now, stuff that we've learned earlier, and stuff we are experiencing in our everyday lives. So my goal is for you to be able to state the ways in which the warming atmosphere will affect ecosystems and organisms. So, starting us off, if we remember way back, for those of you who are here first semester, an ecosystem is all living things and their physical environments in a particular area. So this graphic shows we've got all of the minerals, all of the nutrients, all of the plants, and all of the plants and animals that make up a habitat, the disturbances, the solar radiation, the moisture, every aspect of an area is considered its ecosystem. So, we are going to talk about not only how the warming atmosphere will affect one aspect of that ecosystem, but also how changing one aspect of an ecosystem can throw the entire thing out of whack. If you've remember, or if you've interacted with food webs in the past, right? Everything within an ecosystem is so interconnected that if we throw off one thing, it can kind of throw a wrench in the entire system. So, if we think about how climate change affects an ecosystem, it can do so by by mainly affecting one organism, and that one organism messing up all of the other ones, or it can affect all of the organisms all at once and essentially change an environment irreparably. So we're going to talk about some specific ways that these changes will affect ecosystems, and then you, in the thought questions, are going to try to draw your own conclusions based on things that you think, things that you know. It's not necessarily a right or wrong answer. But so an ecosystem is all living things and their physical environments. One of the big ways that climate change can affect an ecosystem is by shifting habitats. If you've ever been to a plant nursery or tried to grow a garden and gotten those little seed packets, those seed packets usually tell you around what temperature these plants like to grow. Right? Plants have specific temperatures that they like to be in. They have special humidities that they like to be in, that they grow best in. So, if an area gets warmer, it might get too hot towards the high end of that plant's range, and plants in that area can die because it's too hot for them to sustain themselves. Or it can take a nearby cold area and make it warm enough and allow that plant to come into that area. This can cause a lot of damage in a lot of different ways, right? What if that plant was a main source of food for an animal, and now it's too hot for that organism to grow? What if this plant moves into a new environment and there's no natural predators in that environment, and it becomes invasive and kind of takes over everything and pushes out other organisms? When we change habitats, even just by a couple degrees, it can affect where and how plants can grow. And I know plants are the example I've used here, but this applies to animals too. Hate that sound. This applies to animals too, right? Some animals like it hotter than others, some animals like it colder than others. So if it gets too hot in an area, that animal can move to a cooler place and essentially join or disrupt a new habitat. Any questions about habitat shifts? I've got some examples for you. So, California lilacs are an example that we see habitat shifting right in front of us. So, California lilacs normally grow on mountainsides, right? And as climates get warmer, it's warmer higher up, right? So, those lilacs, which would normally stay at the base of that mountain, can now grow higher up it because it is warmer and warm enough for those lilacs to move up the mountain. They have moved on average 65 meters. That's 215 feet outside of the environment that they normally stayed in. Luckily, this didn't cause any major effects to a lot of ecosystems because ecosystems on a mountainside are relatively similar. But if this were invasive or if this was a food source and it had moved, right, that could cause some pretty dramatic effects to food chains, right? Food chains, while very complex, are also relatively fragile. So this is just one example of a habitat shift. All because of a couple degrees shifting in the atmosphere. All right. Another way that climate change can affect habitats is by changing migration times, right? A lot of bird species migrate every year in the fall and spring to places that are warmer or have more food, right? We talk about birds flying south for the winter, right? Because it gets warm in the south. Uh, so some birds are actually starting their spring migrations earlier than before because they're what signals them to move north, right, is that it's getting warmer, right? It's getting warmer, I can move north. If it gets warmer quicker, then they will move north a lot sooner in the year than they would have otherwise. This can throw a lot of stuff out of whack. What if that bird has the same food source as another local bird that doesn't migrate and they move in early and wipe out a certain food source before anybody else? What if there's no food or resources there whenever the birds do get there? If it didn't warm as fast where they were going as where they were. And that is exactly what happened with our example that I'll get to in a second. This is so much fun. This is crazy. So, our example here is robins, right? Every year in the spring, robins will arrive on a mountaintop in Colorado. On average, they're moving into this mountaintop 2 weeks earlier than they had been since the 1970s, right? But with climate change, right, we didn't just talk about global warming, we also talked about increased precipitation. So this mountaintop that they moved to has a lot more snow on it than normal because they're getting a lot more precipitation. So when they get to this mountain, they don't have food when they arrive because there's so much snow covering the ground that they can't access their food source. So all of these birds are in a place 2 weeks early without food. All because where they were got hotter earlier. So this can cause either disruptions in the migration pattern as those birds move on to someplace else, or wind up starving a lot of birds, which is not good for food chains, right? If you wipe out one aspect of a food chain, it can terrorize the entire chain itself. That's another way that climate change can affect ecosystems. There are also a lot of problems obtaining food, right? So with temperature changes globally, the Arctic has been seeing a lot more intense changes than any other ecosystem. I'm sure you have seen pictures of polar bears floating on icebergs for a while. So this is because as the Arctic warms, ice sheets melt and they thin, which makes it really, really difficult for polar bears to hunt the seals that they eat to survive. And we have seen an increased amount of polar bear deaths because they have to swim farther distances in order to get the food they need. This can lead to them dying of starvation or of exhaustion, or if they run out of steam, run out of energy in the middle of the ocean, there's nothing to get to. It can be really, really dramatic. This has put polar bears on the endangered species list. When you think about polar bears know how to swim, and they know how to swim long distances. There was I've heard a couple stories of polar bears swimming from Greenland to Iceland, which is a pretty substantial distance in order to feed because there is food on Iceland and way less animals on Greenland because Greenland's icy and Iceland's green. So polar bears know how to swim. They know how to swim long distances, but as these distances get bigger and bigger and bigger, it can cause major declines in their food sources. Any questions so far? All right. All right. One of the biggest ecosystems that has been taking hits with climate change are coral reefs. As the ocean warms, chemistry changes, and it affects all of the organisms that live in the ocean, specifically corals. Corals are tiny animals that use dissolved chemicals in the water to build hard structures around themselves. And when millions and millions and millions of corals come together, they can form massive ocean structures called coral reefs. These coral reefs do a lot for oceanic ecosystems, right? They are places for shelter for animals. You've seen clownfish living in sea anemones, right? Sea anemones are a big part of coral reefs. Um, little hermit crabs and phytoplankton and zooplankton and all the little bug-like critters that live in the ocean. All of them depend on coral reefs. Coral reefs have a lot of photosynthesizers in them because there's a lot of algae in them. And photosynthesizers, right, are our primary producers. That's how sugars, that's how energy gets from the sun into food webs in ocean ecosystems. So without coral reefs, we lose a very, very, very biodiverse ecosystem, um, which is why one of the biggest hey, look, climate change is causing a lot of issues. One of the biggest pieces of evidence for that is coral reefs. Um, so, coral reefs, like I said, are rich in varied habitats that a lot of marine animals are a part of. Right? There are a lot of fish that rely on coral reefs for housing and structure. Right? It's a hunting ground for a lot of fish. Um, they also protect beaches. So without coral reefs, right, the waves that are in the ocean don't have anything to like buffer them before they hit land. So if a coral reef on the edge of a continent dies off or loses structure or loses mass, the waves that can reach the shore get bigger and bigger and more intense. They also support the tourist industry, right? A lot of people go scuba diving to see coral reefs, to see this like gigantic underwater forest. A lot of people depend on fishing in these areas too. And in order for the fishing industry to survive, right, you need the things that the fish eat. And most of the time, the things that the fish eat live in this ecosystem. So we've got a lot of economic stuff relying on coral reefs as well. Surfing, right? Depends on there being waves that are big enough to surf, but safe enough that it doesn't kill people. Without coral reefs protecting the 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 beach, surfing conditions get harsher and might become unsurfable altogether. There are a lot of different ways that coral reefs support both life in the ocean and outside of the ocean. So, what's happening to these coral reefs? Um, Coral bleaching, right? So, reef building corals, like the corals in the reef, have algae that live within their tissues. These algae carry out photosynthesis and provide nutrients to the corals. When that algae dies, um, that is when coral bleaching happens. Because when that algae dies, right, photosynthesis depends on those pigments. So without those photosynthetic algae, without those photosynthetic pigments, the corals turn white. They lose the vividness that came from those algae. So when the algae die, it looks like the entire coral reef has just turned white or has been bleached. We don't know the exact reason why this is happening. These are very, very, very complex systems, and we have a lot of people dedicated to why coral bleaching is happening. Because if we can figure out why, we can figure out how to stop it. But a lot of people are attributing coral bleaching to two things: increasing temperatures and increasing acidity. So the ocean's pH is decreasing. We'll talk about that in a second. The oceans are getting warmer. These two things, in combination with a bunch of other aspects of climate change's effects in the ocean, are causing coral reefs to collapse. We have lost a lot of coral reefs, and it is very, very hard to recover those. It's like the Amazon rainforest, right? You talked about how the tropical rainforest is the most biodiverse ecosystem on the planet. Coral reefs are up there. There are a lot of different plants and animals that live in coral reefs, and when coral reefs die, we lose a lot of biodiversity. So these are some before and after pictures of coral bleaching, right? We've got these gorgeous reds and greens and purples that just fade into a greenish, yucky, brownish white. Because all of the things in here that were displaying those colors, all of the photosynthetic algae die off, and what is left is this like calcium-based structure that these organisms have built around themselves. So one of the reasons this happens is ocean acidification, right? The ocean is getting more acidic, so our pH is dropping. Remember, low pHs are acidic, high pHs are basic. And this happens because when carbon dioxide gets dissolved in water, it forms carbonic acid. Carbonic acid can then dissociate into bicarbonate and hydrogen ions. Hydrogen ions will increase the pH or decrease the pH. Bicarbonate, carbonic acid, decrease the pH. So the more CO2 that gets absorbed by the ocean, yes, it won't contribute to climate change or it won't contribute to global warming, right? Because it's getting greenhouse gases out of the atmosphere. But we are seeing the effects of what happens when too much carbon dioxide is absorbed into the ocean. And that is a significant decrease in pH. So this is another reason why people think that coral bleaching is happening, right? pH is an important part of any aquatic ecosystem, or even us, right? If we get an acid or a strong base on our skin, it irritates or even burns. Uh, if you like sour candies, right? Those things are sour because they've got that white powder stuff on it. That powder is citric acid. So if you eat sour candy after sour candy after sour candy, your mouth gets kind of painful and gross. It's essentially an acid burn, right? Not a severe one. Usually, you get your taste buds back in a couple hours, right? But imagine that on a much more extreme scale, and being a single-celled algae, it's going to cause some issues. So the acids interact with the algae that live in these coral reefs, and if the algae can't stand it, they will die. So these are just some more effects of ocean acidification. like I said, lower pH will also prevent the corals from forming the outer structures, the strengthening shells, because the bicarbonate is different. It will interact with what their normal chemical uh, reactions that happen. Mussels and starfish have a much more difficult time clinging to surfaces because their suction methods are thrown off by the acidity, right? They don't want to be exposed for very long to the acidic nature of things. Zooplankton are our photosynthetic plankton that are really, really important to the carbon cycle, right? They also are big photosynthesizers. They can die in large swaths when ocean acidification takes place because they can't live in these really, really acidic environments. And also, it can affect bigger fish, right? Fish's cells, because, okay, so you go swimming, you take a bath, you take a shower, your fingers can prune up, right? Your your cells change structure because they were exposed to water for a prolonged period of time. There is a system that your cells use to balance the amount of water in them and balance the amount of water outside of them. When we swim, when we bathe, right, we are going to disrupt the amount of water that they are exposed to, and the cells have a hard time adjusting to that. That's how you get your little prunes. Fish have a different system, but they still need to balance the amount of water that is inside their cells and the amount of water that is outside of their cells. They are adapted to living in saltwater conditions, yes, but as the water gets more acidic, that balance gets harder to strike. It gets harder for them to get the good water in and get the bad water out and maintain their internal pH. We have an internal pH that we like to, right? We are not always a neutral 7 pH, but we like to sit somewhere around there. Our bodies naturally excrete systems that give us a specific pH. Fish are the same way. They like to be a certain pH on the inside too, and with everything around them, it'd be like the air around us getting acidic. It'd cause some issues. So ocean acidification not only affects coral reefs and therefore food chains, but also our larger what we think about when we think about fish that live in the ocean. What questions do you have about this? All right. Um, we mentioned this earlier this week too, right? Warmer ocean temperatures mean that the ocean can hold more carbon dioxide. Warmer the Earth gets, the more carbon dioxide is absorbed, the worse effects there are on oceans. The worse affects the ocean too. That's what wording I use, right? It's that positive feedback loop. Hotter it gets outside, the more carbon dioxide the ocean can take up, the worse those effects get. Hotter it gets outside, the more carbon dioxide the water can hold, the worse those effects get. It is very, very difficult to take carbon dioxide out of water. We can't necessarily add a bunch of bases to the ocean and hope that it balances the pH. Uh, sorry, train of thought again. Uh, so this, as in most environmental stuff, the the way to solve it or the way to approach this is through prevention rather than mediation. And we'll talk about that mostly next week. last slide. When we think about how the future is going to go, and keep this in mind as we move forward in this unit, all of this stuff is really, really complex, right? We think about all of the interactions that happen in all of these ecosystems, in all of these food webs, by all of these individuals, and it makes it very, very difficult to predict what's going to happen next. So we don't know if coral reefs will recover. We don't know what will happen when all of the coral reefs are gone. But it is definitely something to think about when we think about climate change. So if you could answer the thought questions I have posted on Canvas, I will make sure that they are published. If you have any questions, comments, concerns, please let me know. Yeah.